Hello, friendos. We have made it to the end of the unit. This is 6.9. Before we get started with this, I want to tell you this is the last lesson of Unit 6. Unit 7 is easy. Unit 7 is statistics, mean, median, mode, range, graphs, real-world examples. There's a reason why we save it for the end. This is the last lesson of the hardest unit of the entire year. What we're doing in 6.9 is not difficult, but there's a lot of steps, and it's putting together everything you've learned this unit almost. So we're going to go through it piece by piece. Try your best. Slow and steady wins the race. Pay attention to your notes. If you never did 6.1 and 6.8 and 6.6 and 6.4 and lots of other lessons, you might want to go back and do those before if you're getting stuck on this assignment. That might be why. So we're going to go through this step by step. If you need to pause the video and ask questions, please do that. Or please raise your hand and we can pause the video and you guys can ask questions and get things re-explained. But today what we are doing is we are graphing a quadratic, just like we did in 6.4, but now our A value is greater than 1, like it was in 6.6 and 6.8. So we're going to go through piece by piece for the first example, and then we'll do the second example all together. So step 1 is in this first box here. It's to find your axis of symmetry in vertex. We're going to go ahead and graph as we go. So axis of symmetry, we always do negative b over 2a, and then we plug that in to find the y value of our vertex, and we go from there. So let's flip to the back side of this. We're going to do that for our first example. So my a value on this first problem is 4. My b value is negative 16. My c value is 7. So my axis of symmetry is always x equals negative b over 2a. So in this problem, negative b would be negative 16, which would be positive 16, over 2a, which is going to be 2 times 4. So now I've got 16 over 2 times 4 is 8, and 16 divided by 8 is 2. So that is the x value of my vertex, and my axis of symmetry is 2. And I can go ahead and graph that. And I like to graph as I go, because if you graph as you go, you can see if everything's lining up correctly. Right, next thing that I need to do is to find the rest of my vertex. I need to plug in that 2 for x. So I'm going to do 4 times 2 squared minus 16 times 2 plus 7. That is me just plugging in 2 for x. If I wanted to do this piece by piece, 2 squared is 4. 4 times 4 is 16. Minus 16 times 2 would be minus 32 plus 7. 16 minus 32 is negative 16. Negative 16 plus 7 is negative 9. I could also still always do this in a calculator. I slid that a different way this time. So we could do 4 times 2 squared minus 32 plus 7, and I would get negative 9. Awesome. Okay, so we're going to go and graph that to negative 9. It's going to go right there. Okay, so that is all of our step 1. That is everything we did back in 6.1. Now we are ready for step 2. To do step 2, we can either use 6.8 or 6.6. So we can either factor or we can use the quadratic formula. We are going to do one example in one way, we're going to do the other example in the other way, and then you guys can do whichever method you prefer. So we'll start with the factoring, what we did in 6.6. So I am trying to factor, I'm trying to find 2 numbers that multiply to a times c. So a times c in this problem is 4 times 7, that's 28. So I need to multiply to 28, and I need to add together to bb, so I need to add to negative 16. Numbers that multiply to 28 are 2 and 14. I can make those add to negative 16, but still multiply to be a positive by making it negative 2 and negative 14. So negative 2, negative 14. All right, going to take my original problem and rewrite it here. 4x squared minus 16x plus 7. Now I'm going to split that. So I still have my 4x squared. My negative 16x splits into negative 2x minus 14x. And then I still have my 7. Factoring that by grouping now. Out of 4x squared and 2x, I can pull a 2x out of both those. 4x squared, pull out the 2x, leaves behind 2x. 2x divided by 2x leaves behind 1. It's actually negative 1. Negative 14x plus 7, I can divide those both by 7, but because that 14, my third term, is negative, I'm going to divide out a negative 7. So negative 14 divided by negative 7 is positive 2. Still have my x. 7 divided by negative 7 is negative 1. So now I've got 2x minus 1 and 2x minus 7. So my 2x minus 1, I went through that kind of fast. My 2x minus 1 came from here. 2x minus 1, 2x minus 1, those match. So that's my first factor. And then my 2x minus 7 comes from here. All right, now I need to set each of those factors equal to 0. I'm going to use the space underneath my graph. So 2x minus 1 equals 0. I would add 1 to both sides. I would get 2x equals 1. Divide by 2. I'm going to get x equals 1/2. That is one of my zeros. For my other one, I've got 2x minus 7 equals 0. I'll add 7 to both sides. I'll get 2x equals 7. And I'll divide by 2. I'll get x equals 7/2. And we'll leave that as a fraction. Okay. So graphing these, we now have fractions that we need to put on our graph. So when we do that, we just are going to look and just get them between the correct two numbers. So 1/2, I can zoom in super far on this. 1/2 would go between 0 and 1. And then 7/2 is 3.5. So if you put that in your calculator, 7 divided by 2 is 3.5. So it just goes halfway between 3 and 4 on here. All right, so that was step 2. And we did it by factoring this time. On the next problem, we'll do it by the quadratic formula. All right, step 3 is our easy step, finding our y-intercept. We plug in 0 for x, and since we're plugging in 0 for x, it's going to be 0 squared is 0, x is 0, so it's just 0 on that middle term as well. Our y-intercept is always just going to be our c value, so it's always just our c value. So back to our example, our y-intercept here. If I were to plug in 0, 4 times 0 squared minus 16 times 0, that's all zeros, so it's just the plus 7. So our y-intercept here is just 7. We can go ahead and graph that. Then the last thing that we need to do is reflect that, so it's currently 2 to the left, we can go 2 to the right, and we should end up with 5 points. So I've got 5 points now. I'm going to make these two a little bit bigger. Oh, I accidentally deleted one of them. And we can now connect those. It's going to be a really tall, skinny U. So just do your best to connect them. What we're going to be looking at more is your work and the actual point. So if the U doesn't match up perfectly, like mine didn't go through perfectly, it's fine. Don't stress out about it. Okay, so lots of steps, but it's all things we've done before. We're just putting them all together, which makes sense that at the end of the hardest unit of the year, we would be putting together everything we learned. That's the way math works. Okay, we've got one more example we're going to do. Last one we'll do with the quadratic formula, and then we'll go from there. Okay, 9x squared plus 18x plus 5. So my ABC is A is 9, B is 18, C is 5. We'll do B squared, not yet. We will do negative B over 2A to find my axis of symmetry. So x equals negative B over 2A. So negative B would be negative 18. 2A would be 2 times 9. So negative 18 over 18 would be negative 1. So that's my x value. Then putting that in to find my, so that's my x value. Then we're going to plug that in to find my y value. So that'll be 9 times negative 1 squared plus 18 times negative 1 plus 5. Negative 1 squared is 1. 9 times 1 is 9. 18 times negative 1 is negative 18 plus 5 9 minus 18 is negative 9. Negative 9 plus 5 is negative 4. And like always, you could plug that into your calculator as well. So let's go ahead and graph those two things. I've got my axis of symmetry at negative 1. So graphing a vertical line there. And then my vertex is negative 1, negative 4. So left 1, down 4, put a point there. Okay, next thing that we're going to do is quadratic formula. So it's going to be b squared, or sorry, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let me write that down real quick. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then let's plug things into that. So negative b is going to be negative 18 plus or minus the square root of b squared. So that'll be 18 squared minus 4 times my a value my a value is 9, and then my c value is 5. So 4 times 9 times 5 all over 2 times a. So 2 times 9. Okay. 18 squared and 4 times 9 times 5. We're getting into some big numbers here. Let's go use a calculator. So 18 squared minus 4 times 9 times 5 is 144. Awesome. So I have negative 18 plus or minus the square root of 144 all over 2 times a, so 2 times 9, which is 18. And then we are ready to split that. Actually, no, we need to take the square root before we split it. My bad. Square root of 144 is 12. So we'll have negative 18 plus or minus 12 over 18. Now we're ready to split it, and I'm going to split it down here into two different fractions. So we'll do negative 18 plus 12 over 18. We'll do negative 18 minus 12 over 18. So negative 18 plus 12 is negative 6 over 18. Negative 6 over 18, we can divide both those by 6. So if we divide the top by 6, we'll get negative 1. Bottom, we'll get 3. So negative 1/3 is one of my zeros. For my other zero, negative 18 minus 12 is negative 30 over 18. Once again, we can divide those both by 6. Negative 30 divided by 6 is negative 5. 18 divided by 6 is 3. So negative 5/3. All right, so graphing these ones are a little bit more challenging because they're harder to deal with fractions. So negative 1/3, if I put that in a calculator, would be negative 0.333. Negative 5/3, if I put that in a calculator, would be negative 1.66, continuing 7. So going in to graph that, negative 1/3 would be in between 0 and negative 1, but closer to 0. So I'm going to put it right there. And then negative 5/3 would be in between negative 1 and negative 2, but closer to negative 2. So I'm going to put it right there. And again, these aren't going to be perfect. We're just sketching the graphs. We'll get the exact numbers for our zeros when we fill in those blanks, but your graphs aren't going to be perfect. Okay, and then the last thing that we're going to do is our y-intercept. Y-intercept's always just our c value. So in this problem, your y-intercept, c equals 5. So I'm going to graph that. That is 1 to the right of my axis of symmetry. So 1 to the left of my axis of symmetry. So this one's even skinnier than the last one. We'll go ahead and connect all those points. And that, ladies and gentlemen, is a wrap on Unit 6.